All right, so we are just going to do, like I said earlier, we're going to do just the trapezoids, and then tomorrow we'll do the kites. We've talked about a trapezoid. Do you remember what we defined a trapezoid to be? I think we have, haven't we? Yeah, we've talked about what it. We haven't talked a lot about it, but we did talk about what a trapezoid was. So it is a quadrilateral. That's very true. Is it two? Well, it's two sides, but it's one pair of what? Parallel sides, okay? Everybody's watching. It's a quadrilateral with one pair. Nico, go out in the hallway for about 10 minutes. Go. Okay? It's 5 after, so quarter after you can come back in. I want you to stand right so you can see me through the window and I can see you. All right, let's try this again. So a trapezoid is quadrilateral. Jason. A trapezoid is quadrilateral with one pair, exactly one pair. Okay, not at least, because if it was at least, they could have two pair. Okay, it has exactly one pair of parallel sides. Everybody got it? Okay, so what I'm going to do is talk specifically about a thing called an isosceles trapezoid. An isosceles trapezoid. What's that?
Would it be parallel opposite sides or parallel sides?
Well, they would have to be opposite if they're parallel to each other. They can't be next to each other because they would intersect. Okay, if they.
Talking about like opposite,
They don't necessarily have to be the same length, but they have to be parallel to each other. Okay, which means they'll never intersect. So, like this one and this one could not be the parallel sides because they intersect. Okay. But a word for it? I don't know. I'm not sure what you're thinking about. But anyway, these two are opposite each other, but they're parallel, right? And they don't necessarily have to be the same. In fact, they're not gonna be the same length. Okay, everybody understand that? Like that little one right here and this one down here, because if they were the same length, then it would be probably a rectangle, right? If they were the same exact length and they were parallel to each other, all right? But that's not the case here. But what we're going to do, let's label it. Let's call this K. It's supposed to be a K. Oops, there we go. Click that dumb button on the pen. That's J. This is I. And this is H, right? Now, we've talked about that word before, haven't we? But we didn't talk about an isosceles trapezoid. Still starts with a T. What did we talk about? An isosceles what? Triangle, right. So we've talked about an isosceles triangle. What was an isosceles triangle? Do you remember? Looks like this. What was true about an isosceles triangle? You forgot already?
Two sides are the same.
Two sides are equal.
You went to the SIC? Only thing I said was smart.
No, we got you. Nadir, you got credit for it. Okay, you got it. So look, these two sides right here would equal each other. So on an isosceles trapezoid, what do you think might be true? Two sides are equal. Which two sides? The ones that are parallel or ones that are not parallel? Ones that are not parallel, okay? We just said a second ago that the parallel sides are not going to be equal to each other on a trapezoid. You got it? So it's the ones that are not parallel. So if this one was equal to this one, then what kind of a thing do we have? What kind of a polygon do we have? A what? It's right there. It's right in front of you. It's isosceles trapezoid. Just want to see if you're paying attention. All right? Now, we have a theorem. That was just a definition. It wasn't a theorem. All we did was describe what an isosceles trapezoid is. It's a trapezoid with two equal sides. All right? And we call these, this would be called the base. I'll just throw that in there. This would also be called the base. So a trapezoid has two bases. All right? Now, they're going to be different lengths, but we still call them a base. The two equal sides right here, we call the legs. Kind of like a triangle, right? I mean, we have a base of a triangle and we have legs of a triangle. So those would be legs right there. Okay, so the two equal sides would be the legs. The other two, the parallel sides, would be called the bases. And you're going to, not today, I think in the next chapter. No, we do it today. Yeah. All right. We'll call this like base 1 and base 2 because they're not going to be the same. They're not going to be equal to each other, okay? So they're both called a base, but we'll call one base 1 and the other one base 2. Everybody with me on that? All right. So our theorem says this. It says that the base angles, now we're talking angles this time, the base angles of an isosceles trapezoid are congruent to each other. So which ones are the base angles? Well, I'm glad you asked, because I'm about to tell you. So this right here would be a base angle, all right? And same thing with what? This one right here. Why? Because it connects the base to one of the legs. That's the base angle. Are there any other base angles in here? So H and I are base angles. What K and J are also base angles. It doesn't mean that K is equal to H, though, because it's the ones that connect the leg to the base. Okay, they are the ones that are equal to each other. All right, everybody with me? So angle H is equal to what in this situation? Angle I. That's right. So let's write that down. So angle H is equal to angle I. What else is equal as far as the angles are concerned? K and J. That's right. So angle K is equal to angle J. All right. That's what our theorem says. That's basically what it says. I'm not going to write it all out for you, but it basically says that the base angles of an isosceles trapezoid are what? Equal or congruent. A lot of times in geometry they use the word congruent. Most of the time they do. I like to say equal, so we'll just say equal. Everybody got it? Does that mean K and H are equal to each other? No, but they do something, though, without them telling us, and I don't believe there's a theorem on this. Okay, but they are supplementary. How do you know that K and H are supplementary? That's right. You got two parallel lines cut by transversal. Remember that? Seems like we keep coming back to that, don't we? Two parallel lines cut by transversal. What's true about that angle right there and that angle right there? They're not equal to each other. They add up to 180. Okay, so they're supplementary. So what can I say about angle K and angle H? They are what? Supplementary. That's right. So they add up to 180. So what if this was, I don't know, 60 degrees right there? Could you find all the other angles? Yeah. So what's the easiest one to find if I know that's 60? Angle I would also be what? 60. All right. And then what would K and J be equal to? 120. Because how'd you get 120 out of that? You went 180. Well, you didn't have to add them together. You just went 180 what? Minus 60, which is 120. So this angle right here is 120. Since these are equal to each other, this would also be 120. You with me? And you know what they're going to do eventually? They're not just going to give you numbers here. They're going to say like this is what? 3x plus 2 or something like that. This is 2x minus 5. So what would you do? You'd set them equal to each other, solve for x, plug it back in, right? We've done that over and over and over again this year. So that's the kind of stuff that they're going to do eventually. All right? Everybody good on that theorem? Yeah, pretty easy. Now this is only true if the trapezoid is what? Isosceles. It's got to be isosceles. It does not hold true for any trapezoid ever. All right? It only holds true if it's an isosceles trapezoid. So for instance, if let's just draw one just to show you. It's not really a proof or anything, but it's just to kind of give you an idea. So what if we had a trapezoid that looks like this? I'm going to take this way over here like this. All right. Is that a trapezoid? Yeah. Okay. But do you think it's an isosceles trapezoid? Probably not, because look at this angle right here and look at this little angle right here. Do they look the same? No, that one's way skinnier than that one. Would you agree? Again, we're just eyeballing it, okay? This is not any like formal proof or anything. We're just looking at it. So there's no way that that's isosceles. And look at this side right here. This side looks way longer than what this side is right there, okay? So all that stuff about the base angles being equal to each other, it's only true if these two sides right here are equal. These are definitely not equal, and definitely the angles right here are not going to be equal as well. We good with that? All right, let's do another one. So on this one, we said it was an isosceles trapezoid. We've done this a bunch of times too. It said, okay, we're starting off knowing that this is an isosceles trapezoid. Then what's true about the base angles? They've got to be what? They got to be equal. So what do you think they're going to do now? They're going to say, well, what if you have a trapezoid? We don't know it's isosceles just yet. All right, so let me just draw another trapezoid. Okay, like this and like this. I'm just eyeballing it. Okay. Now, I do know it's a trapezoid. So since it's a trapezoid, this and this must be parallel to each other. But that's, actually, it's not all I know. But what if I know? What if they tell me? They didn't tell me it's isosceles, okay? Everybody with me on this? So I don't know for a fact that this side and this side are equal to each other. But I do know, and they tell me, let's turn this yellow. They tell me that this angle is equal to this angle. So they didn't tell me it's an isosceles trapezoid, but they did tell me those two base angles are equal to each other. So what do you think is going to be true about this whole trapezoid? It must be a what? Isosceles. Do you see the difference? On the first one, they told you it was an isosceles trapezoid. So what can we say about the angles? The angles then must be what? The base angles. They must be equal to each other. On this one right here, notice the difference. They just tell you that it's a regular trapezoid, but they tell you that the base angles are equal. So what must be true about this side and this side right here? So watch, what if I did this? And that's the only information I gave you on this. Could you tell what that side is? Yeah, what is it? It's 5, that's right. Because if these two angles are the same and they're equal, it must mean it's isosceles trapezoid. So if this side is 5, then guess what? This side is also 5. You see the difference in the two things? Dominic, tell Nico he can come in. All right. Let's do another one with an isosceles trapezoid. Let's get rid of all that yellow. And I'm just going to copy it. We'll just use the same trapezoid right here, okay? All right, so here we go. Here's one more thing that they tell you. Now we're going to go diagonals. We did that a lot with the parallelograms, didn't we? So we're going to do the same thing with the trapezoid. All right. Yeah, I'll just tell you what the theorem says, basically. Let's do this. A, B, C, D. A, B, C, D. So if I told you, now I didn't tell you it's an isosceles trapezoid yet, okay? But somehow they told you that AC was equal to BD. So that means the what? What is AC? Give me a geometry word to describe what segment AC is. I said it just seconds ago. It's a diagonal. That's right. So AC is a diagonal. Tell me what BD is. It's also a diagonal. Agreed? So here's what the theorem says. If the diagonals are equal to each other, guess what kind of special trapezoid this is? Then it's a what? Isosceles, or I should say. Isosceles. Let's spell it right, okay? It's not that hard. ISOS, right? And then celes. How do I spell that? CELES. So isosceles. That's how I break it down when I spell it, okay? So it's an isosceles, what? Not a triangle, but a trapezoid. All right? So that's what it tells you. So what does that mean then? So like if I said that was 3, all right, and I knew that AC and BD were equal to each other, what could I say about something else here? I could say what? If I know that AD is 3 and the diagonals are equal to each other, I can't hear you. Put a 3? That's a Z. It's a cursive Z. See, it's like that, except I didn't put the little curly Q thing on there. So it's a Z. All right, take my word for it. It's a Z. I mean, you know it's not going to be a 3. Come on, you're just causing trouble. All right? Because I said trapezoid 100 times, right? And so you know that has to be a Z. Whether it looks like one to you or not, you know it has to be a Z. Would you agree? Yes, okay. Subject closed. Goodness. So here's my point. If this is 3, then what else do you know about this trapezoid if I know that's 3? I know that's 3 as well. Why? Because this says if the diagonals are equal to each other, then it's an isosceles trapezoid, which means these two sides have to be equal to each other. All right, let's do an example. I'll just redraw it. Bryce, now you get to stand outside because you're trying to fake that he hit you. All right. What's that? All right, now I got this to work. Bryce, go outside. I'm tired of dealing with this nonsense. So your first step is outside. Guess where your second step is? Yeah. And I'm not just going to allow you just to get talked to. I mean, I'm going to have something happen to you. Okay. All right, so I've got... Well, I'll tell you what I have after I write all this stuff down. I just eyeballed a little bit. I think I might have gone a little bit too long on this side right here, but just use your imagination that it's going to be an isosceles trapezoid, okay? Oh, man, I wrote all kinds of stuff in here, and I don't know what the original stuff was. What section is this? 6.5? Let me look it up in the book real quick. Because I wrote some stuff in red, and I wrote some stuff in black, and I don't know which one is what. Yeah, 278, right? All right, let's take a look. It tells you it's an isosceles trapezoid, so they tell you right off the bat that it's isosceles. And I'll just put trap, so I don't have to put a Z, so Jason doesn't go crazy on me here.
Jason is so immature.
All right, and it says angle ABC. Well, it'd be nice if I labeled it then, wouldn't it? So let's call this A, B, C, and D, and we'll call the one in the middle E. All right, and it says angle ABC is 125 degrees. Where is that? That's this one right there. I'll just put a little arrow. Is that all right? Because it's kind of hard to write it inside there. So I'll just say 125 degrees right there. What else do they tell you? They tell you that AC, line segment AC, let's write it down. AC is 7x. See, I told you they'd put letters in here, didn't I? And you knew they would because they always do. And they also tell you that BD is equal to 4x plus 12. And then they ask you a whole bunch of stuff. So part A, they ask you what angle BAD is equal to. Part B, they ask you what ADC, angle ADC is. So we'll write that down. Part C, they ask for angle ABD. Let's keep going. C, we can fit that in here, can't we? Angle ACD. AED. Oops, let's put the angle symbol, sorry. Angle AED. Find out what that's equal to. And then the last one, AC. That's just a line segment, okay? So we're finding all these angles, and then we're going to find that little line segment AC. Well, actually, it's the whole diagonal, isn't it? Okay? Okay. Let's start with the first one. Angle BAD. Where is angle BAD? Let's do this in a different color. We'll go blue this time instead of yellow. BAD. So I want to find this whole angle right there. Well, that's super easy. You don't even have to think about that one, do you? Why is it 125? Because give me some terminology that we just did, and you should be able to look at your notes and see it. If I was to scroll up this page, you would see it. They're not alternate. They're not alternate interior. They're the base, not leg. The base angles, right? The base angles. Okay, we talked about that. We had a whole theorem on that. Okay, so the base angles are equal to each other. So if this whole thing is 125, this whole thing is 125, and that's what BAD is. See, there's B, there's A, there's D, That's what that is. So that, without doing any math whatsoever, is 125. But, yes. Angle ADC. Every new lesson I always record. It asks for angle ADC. Let's figure out where that is. There's A, there's D, there's C. So I'm going to put 2 arcs there. Why didn't I just put 1? They're not equal to each other. So what's the relationship between this blue one, this 1 arc, and this 2 arc angle? There's you got it. Supplementary. So Jake, what do I do if they're supplementary?
Subtract 125 from 1.
That's right. Because remember, this is 125. That's a little sloppy right there, but that's 125. So you go 180 minus 125, which is what, 55? Okay, so that big angle right there, that whole big angle is 55 degrees, and that's what ADC is, so we'll put it right there. All right, so far so good, right? All right, let's see what else they asked for. ABD. ABD. That's this little one. I'll tell you what, let's do this in a different color. So, yes. Sure. Thought you were going to ask me a good geometry question. All right, so this angle right there, that's ABD. How do we find ABD? Well, you know what? I think I'm missing something. Yep. I was going to say, I was looking at this. I'm getting a little nervous. I'm thinking I have no idea how to find that because I didn't give you all the information they gave you in the problem. I got scared too. So they tell you that this angle right there is 30 degrees. Okay, shh, stop. All right. So if this is 30 degrees, they tell you this is 30 degrees, okay? I didn't figure this out on my own. They told me it was 30 degrees, and I forgot to put that in there. So what is this little orange little angle right here going to equal? It's 30. Now give me a good reason. Alternate interior angles, that's right. Now you're seeing it, aren't you? You got parallel lines. You got this as your transversal. So this one and this one are alternate interior angles. So that has to be 30 degrees as well. And that's ABD. Everybody see it? There's A, there's B, there's D. That's the angle right there. So that's 30 degrees. All right? It's kind of fun, isn't it? Trying to find all this stuff. ACD. Where's ACD? A, C, and D. That's this angle right there. Let me see if they tell you anything else that I'm missing. No, that's all right. We're good. What do you think? Why is it 30? You could do a couple things. Now look. Do you see how this... Everybody look here. See how this big angle D right there is 55? And this little one is 30? So what's this little angle right here? This one? It's 25. So that little one right there is 25. Would you agree? Okay. So, all right. So this whole thing has got to be 55, right? Okay. And then this would be what? 30 because it makes the same angle as this one right here. So if that was 25, then that's 25. Let's see. We might even have to use that, right? So, but what was that? ACD. That's 30. And then AED. Where's AED? There's A, there's E, there's D. So I want to find, let's go different color again, just so we can keep everything straight, because I got all these arcs on here. We'll go pink on this one, okay? This angle right here. Now, are they perpendicular to each other? Like right here, where they intersect, where those diagonals intersect. Are they perpendicular? They are. When are they perpendicular? When it's a what? When it's a rhombus, okay? Is this a rhombus? No. So are they perpendicular? No, they're not. Not on any trapezoid, okay? Will they be perpendicular? All right, so that we're trying to find this one right here. So 30's. So watch, this is going to be 30, correct? Because that's 30. If this is, what would you do? That's 125, this whole thing. So this is 30. So what would this be? Would that be 95? So that would be 95. Then could we find this? Yeah. Add them up, right? Take them away. Or you could do this. Watch. It might be a little easier. This is 30. This is 30. That's 60. So what's that? Right here, where the E is. This is 30 and this is 30. That's 60. What's this? Be 120, right? Everybody see that?
Yes.
And then this one is right next to this. So what's 180 minus 120? So that would be 60 right there. All right. There's a couple ways you could have done that. You could have done this. You could have added 95 and 25 and taken it away from 180 if you wanted to. But I don't know. I thought that was a little bit easier right there. So that's 60. So AED is 60. All right. Last one, AC. Now remember, they told we haven't even used this stuff yet, have we? Okay, because it's the length of the sides. So AC, which is this whole diagonal, is 7x. BD, which is the whole other diagonal, and that's 4x plus 12. What did we just learn a few minutes ago about the diagonals of an isosceles trapezoid? They're equal to each other. So guess what we're going to do with these two things? Let's set them equal to each other, which we've done dozens and dozens of times. Okay? And now let's go ahead and solve for x, and then we can figure out what these. It is very colorful. So subtract a 4x. So what am I going to get? 3x equals 12. Divide by 3, we get 4. So x is 4, but we're trying to find AC, so it's 7 times what? 4, which is 28. So AC is 28. Is it 28 degrees? It's not 28 degrees because it's not an angle. It's a line segment. They didn't give you any units, right? They didn't tell you if it was inches or feet or anything like that. So you just write 28. And there you go. That's how you do trapezoids. We got one more thing about a trapezoid. Send Bryce in. We got one more thing to do about an isosceles trapezoid. Actually, this isn't even about an isosceles trapezoid. This is just any general trapezoid this is true about. Let's do that. Okay, everybody watch. This is something I think is kind of cool. This is not an isosceles trapezoid. Okay? This side right here is quite a bit bigger than this one right here, right? But they are parallel. Now watch what I'm going to do, though. Shh. Just listen. You don't have to say something every single time. Now watch. What I'm going to do is I'm going to find the midpoint of both of the legs of this isosceles trapezoid, okay? If I just highlight it, it actually gives a dot right there, so it tells me where I should put the middle. So if I put a dot right there, that should be right in the middle. If I come over here and I select that, there's the dot right there. Got to click off of it, though, and then right there. Now, if I connect this to this, well, they're all straight lines. They're all straight lines, but what do you think? That's right. So first of all, listen. First of all, if I connect the midpoints of these two legs right here, I have another line that's also parallel to these two lines. So I could put a parallel symbol right there. Okay. Now, what did I do? I didn't just connect any old points. What did I connect? The midpoint. So that means this and this must be equal, and this one and this one must be equal to each other. Everybody with me on that? All right. Let's do this. Since I connected the midpoints, I'm going to call this line right here M. Okay, I'm going to call it M1 actually. I did in my notes, so we did up there. Up here, I'll call B. We could call it B1 or B2. It doesn't matter. I called it B2 in my notes. I don't know why. Let's call it B1 because I did that earlier. All right. Now watch. I'm not going to go through and give you an explanation of why this next thing is true. Okay, but what I want you to do is I want you to just remember it. This is actually kind of cool. The length of M1. Okay. And by the way, we have a name for this. When you have a trapezoid and you connect the midpoints, okay, of the legs of a trapezoid, we have a special name for it. It's called the mid-segment. Yeah, but it's the mid-segment of a trapezoid, okay? It's not the mid-segment. What do we do mid-segment of? Probably a triangle, all right? But this is the mid-segment of a trapezoid because I'm connecting the two midpoints. Everybody got it? So that's why I used M for mid-segment. Now the length of it, now listen, here we go. The length of it is exactly the average of the two bases, right? So if I averaged the two bases, then that would be the mid-segment, okay? Because it's longer than the short one and it's shorter than the longer base, agreed? And so it's the actual average. It doesn't matter how long this. So this is the average of these two things right there. If I give you two numbers and ask you to find the average, how do you find the average of two numbers? Add them up, divide by 2. So if I took the base 1 and I took the base 2, added them up, divided by 2, that's going to give you your mid-segment. Okay? Now, I could give you really easy numbers. What if this was 3 and this was 7? Okay? And I asked you to find the mid-segment. What would you do? Add them up and divide by 2. So 3 plus 7 is 10, and divided by 2. So 10 divided by 2 is 5. Okay, so that would be 5. All right, now if you look at it, it's the average. So look, it's the same distance from here to here as it is from here to here. It should be if it was the average. Would you agree? All right, so look, from here to here is 2. From 5 to 7 is also 2. Make sense? All right. So that's how you do that. Now, let's do an example, and we'll be done. So let me draw another trapezoid. This trapezoid is going to look a little different than I've been drawing. Let's go from here to here. Let's go from here to here. All right. That's good enough. And we're labeling this P, Q, RS. And again, I'm finding the midpoint would be right there. All right, find the midpoint over here. Be right there. And if I connect them, it should be parallel. I was off a little bit there, and it's close enough. All right. And this would be the mid-segment that I just drew right there. So we'll call this M and N. All right? All right. So let's see what they tell you. They tell you that this is, PQ is 4R plus 2. They tell you that this bottom is, it's 2R. Okay, and then the middle is 10. So this is a little difficult, or a little more difficult, I should say, than just giving you the two bases and you have to find the mid-segment, all right? But it's the same idea. It's the same exact idea. Let me scooch this to the side just a little bit, all right? Now, remember what our little theorem said. So we're going to have to do a little bit of math here. So what is the mid-segment? What is the mid-segment on this particular trapezoid? It's 10. And what's that equal? The average, right, of the top and the bottom. So what do? I take the top, I take the bottom, and then what do I do to it? Yeah, add them together, and then after I add them together, I divide by 2. Why? Because I'm finding the average of two things, right? So that's why I divide by 2. You with me? Now, that was the easy part. That wasn't so hard if you understand what the mid-segment is. Okay, the next part might be a little bit trickier for you, but it shouldn't be too bad. I want to get R by itself. Well, I could do a couple things. Let's do this. I think the best thing to do, just add your like terms on the top right here. So I got 4R plus 2R, which is 6R, plus 2. That thing's over 2, all right? You got a couple directions you could go with this, but I'd probably get rid of that bottom 2 right there. So it's being divided by 2. You remember from algebra, if you're dividing something by 2, how do you get rid of it if it's being divided? You multiply. You always do the opposite, okay? So watch how I do this. Everybody watch. Write it down. Look and write. Okay. So what I'm going to do is I'm going to multiply this by 2. Now, if you do that to one side, talk to me. Got to do it to the other side. So you come over here and you multiply that by 2. What happens to that 2 right here? It cancels. That's the whole reason why I multiplied by 2, so that it would cancel out. Okay. And so it worked. Now, I just write down the rest of the stuff. 2 times 10 is 20 equals 6r plus 2. Now the rest is pretty easy. Subtract 2 from both sides. I get 18 equals 6r. Divide both sides by 6. What's r equal to? R is equal to 3. Now, here's the question that they ask. They ask you to find the two bases. They want to know an actual number for this and an actual number for this. Well, that's easy. Just plug back in, right? So you found what r is. So let's do it right here. 4 times 3. Let's do it in our head. 4 times 3 is 12 plus 2 is 14. So that's 14. Everybody look up here. Now, you could just plug it into here. Let's do it. 2 times r, 2 times 3 is what? 6. Now look at it. Let's just look at it and just double check to see if we did our work right. From 10 to here is how many places? From 10 to 14? 4 places, right? So from here to here, right, is 4. What is it from here to here? Well, this is 6 and this is 10, so guess what? From there to there is also 4. Is this in the middle? Yeah, it is. All right, so we could be pretty confident that we got the right answer if it works out that way. Everybody good? Okay. So that's trapezoids. It's a lot to remember. It really is. Let's see. 1 to 12. So let's do this in a different color. So it's section 6-5, and we're doing 1 through 12. Yeah. 1 through 12. Now, I haven't looked, but there's possibly, listen, there's possibly going to be some stuff on here about the kite. Now, we haven't taught about the kite yet. Okay, we're going to do that tomorrow. But if there's stuff about the kite, you can just skip it and just concentrate on the trapezoid problems, okay? I don't know if there is kite problems on 1 through 12 or not. I don't have the book. Well, I kind of do. It's open right here. Oh, absolutely, you can try it. It looks like 1 through. I tell you what. Let's change this a little bit. Everybody, look up here, guys.
Yo.
I'm calling out an audible here. Okay. So instead of 1 through 12, that's on the lesson plan thing. Let's go 1 through 8 because 1 through 8 are all trapezoids. They're all trapezoids. Stop. All right, so just do 1 through 8. Every one of them's a trapezoid, so you should be able to do all of those. Okay? All right. That's it.